about the indoor geolocalization techniques. I will present in the next stage different technologies of indoor geolocalization. And in the fourth place, I will present the artificial intelligence localization system that we propose in synapses and we have developed. So in the five parts, we will present the solutions that we have developed based on the advanced fuzzy logic. I will end this presentation by conclusion and the perspective of this work. So first of all, when we are talking about geolocalization, we are talking about a natural thing. Every one of us is always asking where I am, where are you, which direction are you on. For a long time, we have used the compass for localization and for navigation. Thus, generally, when we talk about localization, we have generally in mind the GPS, the GLONASS, the Galileo constellations. And those constellations are grouped in the GNSS Global Navigation Satellite Systems, which is guiding all the mapping and the navigation on the world. But when we are talking about indoor localization, we cannot speak about GPS or GLONASS. In fact, first of all, we define what's indoor. We have Professor Gregory in his book has defined five ranges of the universe. So when we talk about up to 100 meters, we are talking about indoor range. When it's from 10 to 10 kilometers, from 100 meters to 10 kilometers, we are talking about urban range. Then there is the suburban range, the global, and the satellite range. In this work, we are interested on the indoor range, which is up to 100 meters. So first of all, to define indoor geolocation systems, we can say that it's a system that operates indoor, and it has emerged as a means to render localization and navigation inside buildings, to people and to personnel. So if we ask the question, do you know how much time people spend in indoor environment? People spend 90% of their time in the indoor environment. This is an interesting percentage, which makes us thinking about the concept of localization. So when we talk about localization, we talk about tracking, navigating, positioning, guiding, location-based services, which are emerging that are new types of innovative research domains, mapping also, different names of localization systems. So, and also, we should look on the market. Many big companies are used to work on the navigation and on the location process, like big names, Google, Motorola, Cisco, Samsung, and also there is the in-location alliance. The in-location alliance was developed since 2007, and it contains many companies like Qualcomm, Intel, Nokia, Sony. Those companies worked on building standardization for the indoor localization systems. And this alliance until now contains 70 companies in all. So, first of all, we have two statistics that represent the interest of to be localized indoor. We have the ABI research company, which estimates the indoor mapping technology as will be worth $4 billion by 2018, and we have another research which is conducted by the analyst firm Oplis Research, and which predicts the markets of indoor location as to surpass $10 billion by 2018. So here we can see the importance of working on the problematics of research of indoor localization. So if we cite the problematics, we start first of all by the problem of standardization of location-based services, the optimization of techniques, the mapping, because indoor mapping is not usually available, the complexity of the indoor environment, and Professor Perrier has presented the different problem of electromagnetic compatibility and to mention. So let's first of all expose a resume of the techniques of geolocalization. We have three parameters, different parameters that combine techniques. So for the time parameter, like the time of arrival of the signal, the time difference of arrival, etc., the power strength parameter, which is RSSI, and which is generally used in localization techniques, and the angle of arrival. In fact, the angle of arrival parameter and the timer of arrival need specific hardware for measuring. But for the power strength parameter, it's available where we are covered by mostly of the time by Wi-Fi and other signals. So, first of all, for radio signal strength, here we can represent the anchors that communicate with the persons and transmit the power strength to the server, which will calculate the distance, and using combining methods like trilateration, it estimates the position of the nodes for 2D or 3D trilateration. So they are generally classified in centralized or distributed processing techniques, anchor-free or anchor-based. For example, for fingerprinting, it's anchor-based, range-free or range-based, and mobile on stationary. So here, when we talk about distributed localization, we talk about vector-based, relaxation-based, coordinate system stitching, and hybrid localization algorithms, and therefore recursion-based, and error propagation-aware localization. Those are different techniques which use it in localization in wireless sensor networks. Okay, so for optimization techniques, it's the topic of research which is widely investigated to use gamma filters, the tensor-reduced gamma filter, the ANN algorithm, the data fusion and clustering algorithms, the particular first, etc. So here, you may find here on the presentation a summary of the bibliography of localization systems and techniques especially, and the optimization used on this work. So here we will generally see also the technologies used for localization indoor. Generally, when we talk about WLAN networks, we talk about Wi-Fi. Also, there are systems which use RFID, passive and active tags for localization, like alien taxes. Also, there is the wireless sensor network, which is under propagation now. There is the repeater, the pseudolights. In fact, the pseudolights and repeater are the work of Professor Samama in the navigation laboratory in France. Infrared technology, the camera-based technology. But all those technologies have their advantages and their drawbacks. So for us, we have chosen the Wi-Fi and Zigbee technology. We will explain the reasons for this choice. Wi-Fi is there. It can be exploited really without any cost support. So if we resume a localization system, we can say we use to choose the technology: ultrasound, radio frequency, infrared. If we choose the radio frequency technology, we will base on the distance measurements, fingerprinting, or angle measurements. This is a general view of the localization system, how it can be made. And then for the method, there is the time difference of arrival, the RSSI, the power of arrival. Then techniques, which is based on trilateration, cartography, and triangulation. So for our proposed system, it's based on artificial intelligence. And artificial intelligence of using fuzzy logic is always the problem of, are we going to talk about crisp locations, or we are talking about linguistic locations? Generally, human being can think on an X, Y, Z coordinates. A human being, for example, to be localized, hey, we ask you are near the desk, you are in the room A, near room B, high reliability. So when we model the propagation model indoor, we are talking about function which realize the distance, the frequency, the experiential distance, per law of generation, loss factor, and the number of floors. It's defined by the ITU. It's the model proposed by the ITU, International Telecommunication Union. It's a site-specific model. So the fuzzy concept here, we will use there is two sections on the fuzzy concept. There is the linguistic fuzzy modeling and the precise fuzzy modeling. The linguistic is based on the Landini model, and the precise is based on the Tageshi-Seguin model. So in this work, we have proposed two strategic approaches. In the first approach, we will develop a signaling system which is made of sensors. It's a wireless sensor network and uses ZigBee communication. In the second approach, we will use the existing wireless infrastructure, which is the Wi-Fi, and we will use the international navigation sensors on the smartphone for dialing. So in the offline phase, we will do a fuzzy printing of the site, of the map, and the online phase, there is a comparison between the stored database and the online measurements of the RSSI. So here, a schematic description. In the learning phase, we have collected the RSSI from different angles or access points. We have on the map of synapses take the fingerprints. We have to an underlying type 2 phase processing. It's a type 2 of fuzzy logic, which differs of type 1 by a margin of uncertainty that is introduced. So, and then we define a fuzzy location indicator. The fuzzy location indicator will divide the map onto small zones, small zones, and we will combine it on the online phase using the inference engine based on the rule-based defined it. So here, the interval type 2 fuzzy logic, which used a footprint of uncertainty to define, because of the instability of RSSI signals and the perturbation in the indoor environment, we will use altitude to minimize this uncertainty. And thus, when we have a crisp output on the final stage, we will be localized. So an experimental test bed, we have here proposed, we have installed in Synapses localization platform, which is based on the kit STM32W, and we have used anchors as the STM32-100AW4 as anchors. We have done tested inside the environment of Synapses, and we have collected different results. So ZigBee, just a word about ZigBee. ZigBee is a protocol which is distinguishing between the Bluetooth and Wi-Fi, especially by its extensibility. We can reach 65,000 nodes, and also by its energy harvesting. It don't consume much energy. And there is also a big propagation of the ZigBee Alliance, with the ZigBee Alliance, which contains also many companies like Huawei, Schneider, etc. So there is a big opportunity to work on this field. So here we have the first results, which our system have attained 30% of success, and this work will be presented on the EWCNC Intervisory Conference, which will be held in Croatia. Also, we have developed a mobile application. This mobile application is based on three concepts: localization, cartography, and navigation, and combines the ENS for navigation. So, for Wi-Fi, it's cheap, ubiquitous, and indoor and outdoor coverage, and there is also a privacy. Here we should take into consideration. Here, a little description, about the inertial navigation sensors in smartphones, which contain the accelerometer, the gyroscope, and barometer. And here it's the the architecture of our system, which is based on the client, Android client, application server, cryptographic server, and data servers. Here, the application communicates using web services, and the client Android communicates with the GIA server and extracts data from the PostgreSQL here we have used for data. So here we present to you the developed mobile application, Android application. We have taken the map of synapses, and we have taken the fingerprints. You can see here that the access points, the strength of the access points are colored by a special range for such of power strength. And then we can take the position for the learning phase and store the fingerprints that are taken. And in the offline phase, we have the localization of the person using his smartphone. We have the canvas access rate up to 90% for zoom level, because we are not talking here about XYZ coordinations. We are talking about zooms while we are using a fuzzy process for localization. And this work also is submitted to publication. So, in conclusion, we can say that localization is a fuzzy innovative domain. There is advanced techniques that can be used of fuzzy logic in localization. There is an innovation in location system architecture, and one challenge to it. We can also see that here they are anchor-based, those systems, and they depend highly with the anchor's position. So the administrator, or as we speak in fuzzy logic, we talk about the expert which builds the system, is responsible of taking care of the position of the system to guarantee a perfect localization. So here, synapses consider the high level of competitiveness in such field and rely on its innovative solution to gain the best position in the market of localization. In the perspective of this work, we will include the crowdsourcing. Crowdsourcing means the backs, the qualifying of the intervention of the user of the system. So the user of the system can reply and say it's okay, it's good position, it's not good position. That's what we call crowdsourcing. We should handle better the RSSI fluctuations, which is through the concept of footprint of uncertainty. We should take care on working on the linguistic rule base. Also, we should have the precision, reduce the high computational cost compared to type 1 fuzzy logic systems. So thank you very much for your attention.
Oui. La première question, c'est